Welcome back to Management 416. In this video lecture, I will be covering Capstone's production department. In the production department, you will set production schedules and manage the majority of the company's fixed assets by buying or selling capacity on your product lines and purchasing machinery to automate your product lines. In the marketing lecture, we talked about the importance of developing your own forecast, and we used the customer survey score to do so. Your forecast, however, will never be 100% accurate. There are several reasons for this. For example, competitors may unexpectedly enter or exit market segments. They may increase their promotions or sales budgets, or they may slash prices. When you are forecasting, you can only guess what your competitors are going to do. In the production department, we are going to try to manage the risk of stockouts by setting an inventory policy. You, as your company's CEO, need to decide what level of inventory is acceptable. Most companies are willing to carry 1 to 3 months of forecasted sales in inventory in case sales are better than expected. A lower inventory means a higher risk of stocking out if sales are better than expected. A higher inventory means a lower risk of stocking out, but potentially higher inventory carrying costs. So this is really a balancing act. By producing 1 to 3 months more than your forecast, the company is ready to sell more than its forecast when demand is higher than expected. So they won't stock out if sales are higher than expected. On the other hand, the company will not end up with a huge inventory if sales are as forecasted or worse. In the previous video lecture, we demonstrated how to enter the actual forecast in the marketing department. Since we are willing to carry 1 to 3 months in inventory, we will need to make sure that what we have available for sale is our forecast plus an additional 1 to 3 months of sales. The pro formas assume that your actual sales will equal your forecast in the marketing department. Therefore, they will assume that whatever you produce extra will end up as inventory. The pro formas project a worst-case scenario, where you produce more to meet extra demand, but the extra demand does not materialize. In the next video lecture on the finance department, we will talk more about how to adjust entries in the finance department to make sure that if this worst-case scenario comes true, we still have a positive cash balance at the end of the year, and we will not need an emergency loan from Big Al. If, however, this worst-case scenario does not come through and we sell more than our original forecast, we will not run out of product, but also our financial statements will be healthier than what was projected by the pro formas. During the marketing lecture, we developed a forecast for our low-end product acre of 1,839,000 units. You can see that this forecast appears here under Unit Sales Forecast in the Production Decision interface. We talked earlier about setting an inventory policy. While you need to decide about how many months of inventory your company is willing to carry, let's assume that I decide to set an inventory policy of 2 months. That means I am willing to carry 2 months of inventory on top of my annual sales forecast, and all of that together will be available for sale. We will need units covering 12 months of forecasted sales plus an additional 2 months, so 14 months of sales in total. The 12-month forecast for acre was 1,839. If we divide that by 12, we get the 1-month forecast for acre at 153.25 units. We can now multiply this by 14 to get the 14-month forecasts. This yields 2,145.5 units, rounded up to 2,146. I want to make sure that I have 14 months of forecasted sales available for sale in round 1, for a total of 2,146 units. Now that we have this number, I can set my production schedule. I can see that I still have 39,000 units in inventory, so I do not need to produce those. If I want, 2,146 units available for sale, and I still have 39 units in inventory, I would need to produce 2,107 units next year. So let's put that in the production schedule. We put 2,107 units in our production schedule for acre. Note that our actual production after adjustment is lower, with 2,086 units produced, even though our production schedule was set to produce 2,107 units. Production after adjustment takes into consideration some constraints, and you can learn more about that by clicking on the information button behind production after adjustment. For example, with our existing 30-day accounts payable policy, suppliers will withhold 1% of materials, and this at times can disrupt our production schedule. There are other reasons why your production after adjustment may be lower, so you should always keep an eye on this number. Since we truly want to have 2,107 units produced, we can increase our production schedule until production after adjustment matches 2,107. You can see here that we adjusted our production schedule through trial and error to 2,128,000 units in order to have our production after adjustment match the units that we wanted to produce. The second section in the production analysis gives you an overview of your margins. You can see how much of your second shift you are using in order to achieve your production schedule. Right now, only Acre is using 52% of the second shift. We can also see what each unit costs us qua labor and material cost, and we are also presented with the total unit cost, which is the sum of the labor and the material cost. The margins section also projects the anticipated contribution margin. Contribution margin is defined as price minus variable costs divided by price, or more completely, price minus labor cost minus material cost minus inventory carrying cost divided by price. In short, it is the percentage of the price that is left over after covering variable costs. From this, you pay for the remaining fixed expenses and eventually produce a profit. In the calculation of the contribution margin for the production spreadsheet, inventory carrying costs have been set to 0 because they are ambiguous at this point. The contribution margin shown here is simply price minus labor cost minus material cost divided by price. You should aim for a contribution margin of 30% or higher. This should allow you to cover fixed costs such as R&D, promotions and sales, and still have some profits left. In the next section in the production spreadsheet, you can manage your physical plant. Your first shift capacity is the number of units that can be produced on an assembly line in a single year with a daily 8-hour shift. Acre, for example, has a first shift capacity of 1,400, and these numbers are in thousands. An assembly line can produce up to twice its first shift capacity with a second shift. Therefore, Acre's assembly line can produce 2,800 units using a first and second shift. Let's go to the Capsim interface and put in 2,800 units in the production schedule for Acre. Here is our production schedule. Here is the production schedule we had come up with earlier. Let's change it to 2,800 to see what would happen. With 2,800 units in a production schedule, we would now be using 100% of our second shift production. What would happen if we put in 2,801? If I put 2,801 units in the production schedule for Acre, you can see that the simulation turns the number red and crosses it out, meaning that it is not possible to produce 2,801 units. For now, let's put the production schedule of 2,128 units that we had set earlier back. Second shift labor costs are 50% higher than the first shift because they are overnight workers. Nonetheless, it is a good idea to use a second shift because this will mean that you are using your assembly lines more often and depreciation expenses can be spread over more units. There is a specific cost to buy more capacity, which is higher for more automated plants. Each new unit of capacity costs $6 for the floor space plus $4 multiplied by the automation rating as depicted in the formula here. Take a moment to calculate how much it would cost to buy 100,000 new units of capacity if a product's assembly line automation is 5. You can pause the video while you do this calculation. We take $6 for the floor space and $4 multiplied by the automation rating. Okay, the automation rating was 5. This is the cost per unit. Since we are buying 100,000 units, we need to multiply the cost per unit with the number of units bought. You will see that this formula will put out a cost of $2,600,000 to purchase these 100,000 units of capacity for an assembly line with automation 5. Do you remember how long it takes for increases in capacity to take effect? Increases in capacity require a full year to take effect. Increase it this year, use it next year. Let's go to the production worksheet and enter 100 to purchase 100,000 units of capacity per acre. The needed investment appears on the bottom of the physical plant section and shows that it would cost us $2,600,000 to purchase this extra capacity. Please also note that our first shift capacity remains at 1,400. We will not be able to use these 100,000 extra units until a year from now. Similarly, our second shift production percentage remains at 52% and has not gone down. Capacity can also be sold if you have too much planned. Capacity is sold on January 1st for 65% of the purchase price. Take a moment to calculate how much cash we would receive if we sold 100,000 units of capacity if our product's assembly line automation is 5. And we had just calculated that it would cost us $2,600,000 to build. Pause the lecture to try to calculate this. The production spreadsheet will calculate this automatically and display it for you, but we will do it here manually as well. We can see that when we sell 100,000 units of capacity for an assembly line with automation level of 5, we would receive $1,690,000. Do you remember how long it takes for decreases in capacity to take effect? When capacity is sold, the sale completes immediately and the money is available in the current decision year. Let's go to the production worksheet and enter -100 to sell 100,000 units of capacity per acre. The investment appears on the bottom line of the physical plant section as a negative number and indicates we would receive $1,690,000 in cash when we sell 100,000 units of capacity of acre. Please also note that our first shift capacity immediately dropped from 1,400 to 1,300. Decreases in capacity take effect immediately. Similarly, our second shift production percentage went up to 63.7% from 52% earlier. That is because our first shift capacity is now lower, and so we need to use more of our second shift. Selling off all capacity will terminate a product. When you liquidate, the proceeds of the sale of your inventory will be negative because you are selling for half the average cost of production. If you want to liquidate a product but still sell your inventory at full price, you can do this by reducing your capacity to 1 unit. Once all inventory is sold, you can then sell that one remaining unit of capacity. When you produce more than your first shift capacity, you will start to use your second shift. Second shift labor costs are 50% higher than first shift labor costs. Please take a moment to think about how you can offset those higher costs. You can offset labor costs by investing in automation. Automation reduces your labor costs. For each unit increase in automation, you decrease your labor costs by about 10%. Raising automation is expensive. It costs $4 per unit for each increase in automation level. Please note that decreasing automation costs the same amount as increasing automation. You cannot sell automation. If you change automation, that means you need to retool the robots on the assembly line, and it costs money independent of whether you increase or decrease the level of automation. Let's look at an example and calculate the cost of increasing automation by 1 for acre, which has a first shift capacity of 1,400,000 units. Take a moment to do this calculation yourself. The cost to increase the automation level of acres assembly line by 1 is 5,600,000. $4 times the level increase, you increased automation from 5 to 6, so 1, times the number of units. Let's try it out in Capstone. First, let's raise our automation rating by 1 and see how much we would need to pay. You can see here that it would cost us $5,600,000 to increase the automation on the acre assembly line by 1. Instead of increasing it by 1, let's decrease it. So instead of from 5 to 6, we would go from 5 to 4. You can see that we still need the same investment amount. So it doesn't matter whether you increase or decrease automation, it will always cost money. However, decreasing automation does not seem like a smart move. Changes in automation do not happen overnight, and just like increases in capacity, they take a year to take effect. If you invest in automation this year, you will see the benefit next year. Each point of automation decreases labor costs by approximately 10%. At an automation level of 10, you need very few employees to run your plant. Just remember, there is a flip side to raising automation. The more you automate, the longer it will take to reposition products in R&D. Because revising the product means reconfiguring all the robots on the assembly line to match the new specifications. Therefore, markets that require frequent repositionings should not be automated too high. Here are some suggested automation levels per market segment. You can see that the markets that require more frequent product revisions have lower ideal automation levels to balance the cost of labor with the ability to redesign products quickly. There are 2 more areas I want to point out in the production department. The first is max invest. This shows you the maximum you can invest this year in your physical plant. So for the first year, the maximum you can invest is a little over $32 million. The maximum amount that you can invest is determined by a few factors, but most importantly, the maximum amount of cash that your company can raise through stock and bond issues. You cannot invest more in your physical plant in the current decision year than the amount provided here. There is also another opportunity to adjust accounts payable policy in the production department. An important concept related to production is plant utilization. Plant utilization is the percentage of time that your plant is being used. 100% plant utilization means that your plant is used fully by the first shift. 200% plant utilization means that your plant is used fully by the first and the second shift. For acre, we had a production schedule of 2,128 units and a first shift capacity of 1,400 units. This means plant utilization for the acre assembly line is 2,128 divided by 1,400, which equals 152%. Since we know the low-end market grows each year, we will probably need to purchase additional capacity next round to keep up with demand for acre. It is important to keep plant utilization in mind. If your plant is underutilized, it may make sense to sell capacity and invest the cash that you make from that sale elsewhere. You also want to make sure you do not get in a situation where you would need over 200% plant utilization in order to meet your production schedule. You will simply not be able to meet that production schedule because you are not able to use a third shift, and you may miss sales opportunities by stocking out. This is the production analysis page of the Capstone Courier. You can see the plant utilization per assembly line in the right column. On average, we are underutilizing our plant at 75.2%. Hence, it may make sense to look into these assembly lines and determine whether you should sell capacity in some of them. You should consider selling capacity if you do not think you will need it within 3 years from today. I want to remind you again of the importance of aligning your decisions with your strategy. The online help guide in Capsim provides helpful tactics for each department for each of the 6 strategies. If you were to choose the broad cost leader strategy, you would want to increase automation levels for all assembly lines, but more so in the slower moving traditional and low-end segments. Cost leaders, because they automate more, also prefer using a second shift over capacity expansions. Make sure to go to the online help guide and familiarize yourself with the 5 strategies and tactics for the departments. I will go back to the Capstone interface and show you where to find the online help guide. You can click here on help, and from there you can go to online help. You can then search for any topic you wish. In this case, I want to find information about the strategies. Here you can find the 6 basic strategies. We have been covering the broad cost leadership strategy, but you can find information about all the other strategies here as well. Finally, before we end the production lecture, I want to point out one more thing that most of you by now will already have realized. And I'm going to do so by showing the production analysis of the Capstone Courier. You can see all the products that are being produced in the industry here, and you can recognize which products belong to which company by their first letter. All of Company Andrews' products start with an A. All of Company Baldwin's products start with a B, and so on. When you are playing individually, you always are Company Andrews. Once we move into teams, you may be assigned to manage any of the 6 companies in the industry. That's it for the production spreadsheet. The next lecture will cover finance.